Hello, my name is Aurelius Rains. I am going to teach you how to write and understand binary code. So let's just go ahead and get started with that. First of all, let's talk a little bit about what binary code is, right? So we're going to learn today about binary code. And I want to talk to you a little bit about what binary code is. And so what I want you to do is I want you to imagine that, it's 4,000 years ago and you are a sheep farmer. You got a bunch of sheep and you need to count those sheep, right? What do you think was one of the first tools we had in order to start counting things? You guessed it, your hands, right? And if we look at our hands, right, we'll notice that we have in total 10 fingers, which means that when we're ready to count, we can just go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, which means is that we count things in degrees of 10. And when you think about it, like when you're a little kid, people are always telling little kids, count to 10, count to 10. And a lot of it has to do with the fact that we are creatures with 10 digits on our hands. And so this is probably the first thing we started counting with, and then the first one we started keeping up with things before we started inventing things like, the abacus and the calculator, right? But I want you to imagine, what if we had been born with only 2 fingers. That's it. Just 2 fingers, right? So we just have 1 and 2, right? Well, if we were just counting with 2 fingers, now it becomes a little bit different, a little bit more complex. And it's definitely not the way we're used to counting, but I'm here to tell you that you can go ahead and make any number with 2 fingers, all right? So this right here is what we call base 10, or we call it decimal. Decimal counting, right? This is, what do you think the name's going to be? Base what? You guessed it, base 2. It's going to be base 2, right? Or binary counting. All right? So binary, that means that you're only counting using 2 digits, right? And those digits are not actually going to be 1 and 2. The 2 digits we're going to use here are actually going to be 0 and 1. So base 10 is really great for humans, okay? But computers are different. And we're used to very, very complex computers now. But I want you to imagine, right? You are a computer, right? You're a computer, and the only way you have of communicating with people and with input is a very simple way, right? And again, it is the very first way that a lot of us think about computers when we're talking about using a computer and operating a computer, right? Because when you're talking about the power on a computer, right, you either mean off or on. Either the computer is on and it's working, or it's off and it's doing nothing. And so computers really only understand 2 words. They either understand off or they understand on. Right? They only understand off and on. Okay? Now, the best way in order to represent off is to change those 2 ideas into numbers, to write them as numbers, right? And so what we're going to do is we're going to write off as 0 and on as 1. Off is 0, on is 1. All right, so what does all of that mean, Mr. Rains? What does all of that mean? Let's go ahead And let's talk about computers and how they communicate and how we use binary codes to communicate with them. So here's our computer, right? And our computer only understands off and on zeros and ones, right? So whenever a computer talks to us or we talk to a computer, the very basic fundamental language that we use to talk to that computer is in zeros and ones. But how do we understand that, right? How do we understand what this number is supposed to be? I'm going to show you how to understand how to read binary code, and this is the very basic language that we use to talk to computers, all right? So let's go ahead and let's use a little bit of our math skills, all right? And I promise you, don't get upset if you're not a really big math person, if you're scared of math. This is going to be very, very easy, and all you really need to understand in order to do this is basic addition, okay? So for instance, first what we have to do is we have to go ahead and make our codex, all right? We have to create a codex that lets us know how the numbers work. So what I'm going to do is we're going to create our little codex. Let's see, I'm going to use pink here for our codex. And let's just start adding numbers. Now, we already got 0. We're not going to worry about 0 right now. But let's start with the number 1. Okay? Now, if I take the number 1 and I add it together, right? 1 plus 1 equals what? What does 1 plus 1 equal? Anybody? Everybody? That's right. It equals 2. Now I'm going to take this number 2, and I'm going to say, okay, what does 2 plus 2 equal? 2 plus 2 equals 4. Now, if I take 4 plus 4, that equals 8. And 8 plus 8 equals 16. And 16 plus 16 equals 32. Right? And let's just say 32 plus 32 equals 64. Okay. Now, this is what's called a matrix, okay? And this is like the template we're going to use in order to translate our base 10 numbers, right? Our base 10, remember, into base 2 or binary numbers, okay? So now, what I need you to do is to throw out a number. I'm going to go ahead and use my number first. I'm going to put my age in there. I'm 44 years old. I'm 44 years old, right? And what I want to do is I want to turn my age, 44, into a binary number, okay? So how would I do that? Well, let's just go ahead and let's use like a little algorithm, okay? Let's use the algorithm. First of all, I'm going to do is I'm going to pick the number on this matrix. I'm looking for the number on this matrix that is the closest to my age, okay? And since 32 is the closest to my age without actually going over, I'm going to pick 32. And remember, 1 means on and 0 means what? Off, right? 1 means on and 0 means off. All right, so if I go ahead and I see the number 32 here, I should turn the number 32 on. I need 32 to be on, so I'm going to put a 1 here. Okay, so now I got 32. Now I still need to add up enough numbers to get to 44. So 32, I want to get to 44. So if I do 32 plus 8, that will get me to 40. So I'm going to turn on 8. Now I have 32 plus 8, and that'll get me to 40. Okay, and let's see here. Let me zoom in a little bit, just to make it a little clearer to read. All right, so I've gotten that far, and now I want to go to 44. Well, I'm already got 32 plus 8, which is 40. If I add one more 4, that is 44. So I've turned on 32, 8, and 4. If I just go ahead and do the math really quick, 32 plus 8 equals 40. And 40 plus 4 equals 44, which is my age. Yes, I am old. All right. Now, since I had to turn all these on, these are the numbers that I need. I don't need the rest of these numbers in order to get 44. And so I make sure I turn these numbers off. Okay. I've turned the rest of the numbers off, okay? Which means that if I want to signify my age, right, I'm going to write it as 0, 0, 1, 1, 0, 1, 0. This is my age in binary code. This means 44 if I were to convert that binary code into base 10 or decimal code.